Okay, graphs of log functions, Unit 9, Day 3. We're about halfway through this unit now. So, the parent function is just f of x equals log of x. Now, log of x always crosses the x-axis at 1, 0. Every single time, unless we're moving it right or left, it crosses it, right or left or up or down, it crosses at 1, 0. And it just goes like that. The asymptote is x equals 0. It goes right along that. Then it goes to positive infinity. Okay. 10 to the x power, on the other hand, crosses at 0, 1. And it's that function right there. So those are the ones, 10 to the x. That's like the ones that we've been graphing. Now we're going to get into log functions. So log is the inverse of an exponential function. And we're going to use that information to graph these functions. Okay, so let's look at this one. So we have log base 2 of x. There are no transformations done to this. And there's no way to put log base 2 of some number into our calculator unless we were to use the change of base formula. It just gets too messy. So we're just going to take this piece right here, so 2 and the x, and we're going to use 2 to the x. That's what I'm going to put into my t-chart. So I'm going to plug -2 in for 2 to the x, and I get 0.25. So that's my y value there. Do -1, and that's 0.5. 0 is 1. 1 is 2. And 2 is 4. Maybe it's 4. Okay. Now, that is 2 to the x. And I could just graph that if we were graphing f of x equals 2 to the x. But we're graphing f of x equals log base 2 to the r2 of x. And 2 to the x and log base 2 of x are inverse of each other, so I just have to invert this, which means I need to switch my x and my y values. So whenever you invert something, you just switch the x and the y values. So that's going to be 0.25 and -2. 0.5 and -1, 0 or 1 and 0, 2, 1, 4, 2. That's what I'm going to graph. So at 0.25, I go down to -2. At 0.5, I go down to -1. At 1, I go to 0. 2, I go to 1. 4, I go to 2. Then I can graph that. Okay, so you still do those 5 points, -2, -1, 0, 1, 2. But once you do that, we just have to invert it. That's the only difference between the log and then your regular exponentials, is you have to invert it before you can graph it. Okay, so my domain is the x values. X is greater than 0 because it never goes less than 0. It never crosses over that axis. Range is the y values. That's all real numbers. Now, in behavior, as x goes to 0, x doesn't go to -infinity. It goes to 0. This value right here and this value will always be the same. So if this was like a 4, this would have been a 4. If this was 100, this would be 100. Okay? So as x goes to 0, f of x goes to -infinity. And as x goes to positive infinity, f of x goes to infinity. Okay? X-intercept, it crosses right there at 1, 0. Then my asymptote is the same as my domain, so x equals 0. Let's do another one. So we have log base 1/3 of x. So I'm going to first do 1/3 to the x power. So 1/3 to the -2nd power is 9. 1/3 to the -1st power is 3. 1/3 to the 0 power is 1. 1/3 to the 1st power is 0.33. 1/3 squared is 0.11. Okay, now I have to invert this. So I have to do the inverse. I'm going to switch my x and my y values. So my x values are now 9, 3, 1, 0.33, 0.11. My y values are -2, -1, 0, 1, 2. Okay, and I'm just going to graph these. At 9, I go to -2. At 3, I go to -1. At 1, I go to 0. 0.3, I go to 1. 0.11, I go to 2. And there's my graph right there. Okay, now my domain is my x values. That's x is greater than 0. Range is my y values, all real numbers. End behavior, as x goes to 0, f of x goes to infinity. And as x goes to infinity, f of x goes to negative infinity. My x-intercept is 1, 0. My asymptote is the same as my domain, so x equals 0. Cool? Now let's get into this one. So first, this has a transformation on it. So that -1 moves it right 1. So I'm going to go right 1. I'm going to draw my new axis. Okay, and remember, the axis is only used to plot the points. When you're finding domain, range, end behavior, x-intercept, and asymptote, you go back to the original one. So then I'm going to do 4 to the x power to fill out my first t-chart. So that's 0.06, 0.25, 1, 4, 16. Then you invert this. So my x and my y values switch places. There you go. So it would be 0.06, -2. 0.25, -1. 1, 0, 4, 1, 16, 2. And I'm going to graph these points off of my new axis. So at 0.6 or 0.06, I go down to -2. 0.25, I go to -1. 1, I go to 0. 4, I go to 1. And 16, I would go to 2, but that's off the graph. And I'm just going to draw that right there. Okay, so my domain is my x values. Remember, we're working off the original now, so this is x is greater than 1. Range is the y values, all real numbers. And behavior, as x goes to 1, because this and this are always the same. So that's 1, so then that one's 1. Because 1 is the smallest value this will ever get for the x. So as x approaches 1, f of x goes to negative infinity. And as x goes to positive infinity, f of x goes to positive infinity. My x-intercept is right there at 2, 0. Then my asymptote is x equals 1. Cool? Let's do another one. So we have log base 3 of x minus 2. That -2 moves it down 2. So I'm going to just draw that new axis right there. Then I'm going to do my t-chart for 3 to the x. So that's going to be 0.11, 0.33, 1, 3, 9. But then I have to invert this. So I'm going to switch my x and my y values. So I get 0.11, -2. 0.33, -1. 1, 0, 3, 1, 9, 2. Okay, and then let's graph this. So at 0.11, I go down to -2, and I'm graphing this off my new axis. At 0.33, I go down to -1. 1, I go to 0. 3, I go to 1. 9, I go to 2. And then that's my graph right there. Now my domain is the x values. So that's x is greater than 0. Range is the y values. So that's all real numbers. And behavior, as x goes to 0, f of x goes to negative infinity. And as x goes to infinity, f of x goes to infinity. X-intercept is at 9, 0. And my asymptote is x equals 0. Cool. Save those last 2 examples for class, and remember to take the quiz. Your guys are so awesome. See you tomorrow.